The universe could be the hologram is a fascinating concept rotating in certain interpretation of quantum physics and theoretical physics. This rotation came from the study of black hole and the theoretical framework of string theory. In simple terms, the holographic principle suggests that all the information in the region of space can be encoded on the boundary. It's likened to how a hologram works. A two-dimensional image is encoded on a two-dimensional surface. Similarly, in this view, the three-dimensional universe could be encountered on the two-dimensional surface surrounding it. This concept has emerged from attempts to reconcile quantum mechanics with gravity, as traditional physics suggests to explain the behavior of black hole and the nature of space-time at very small scales. String theory, for instance, suggests that the fundamental building blocks of the universe are not particulars, but tiny strings vibrating at the different frequencies. The holographic principle is one of the surprising consequences of this theoretical exploitation. While the holographic principle is a tantalizing idea, it's still very much a hypothesis and lacks experimental confirmation. However, it had leads to integrating inside and continues to drive physics. It has led to intriguing insight and continues to drive research at the forefront of theoretical physics. The holographic principle is a conjecture in theoretical physics that suggests the information within a volume of space can be completely encoded on the boundary of that space. This idea originated from attempts to reconcile the principle of quantum mechanics and general reality, black hole and information paradox. One of the original of the holographic principle is a study of black hole. Black holes are regions of space where the gravitational pull is so strong that nothing, not even light, can escape from them. According to classical physics, when matter falls into a black hole, it appears to disappear. String theory is a theoretical framework in physics that attempts to describe all fundamental principles and focus as tiny vibrating strings. String theory suggests that space-time has no more dimensional than the familiar three spatial dimensional and one of time dimensional. However, these extra dimensional are complexified and not directly observed at large scale. The holographic principle gained significance with the development of anti-shuttle space and correspondence postponed by physics John Mandolina in 1997. This correspondence established a relationship between certain theory of gravity such as Einstein's general relativity in a space called anti-shuttle space, and certain quantum field theoretics define as the boundary of that space. According to holographic principle, the information within a volume of space can be entirely encoded on the boundary. This implies that the three-dimensional reality we prescribe might be a kind of projection for a lower dimensional surface. Think of it like a holograph A three-dimensional image is encoded on a two-dimensional surface. Similarly, the holographic principle suggests that our three-dimensional universe could be encoded on a two-dimensional boundary surface. Further prospective space-time would be not fundamental but would emerge for the interaction of quantum field of on this boundary surface. This would imply that space-time as we perceived it on not the fundamental fabric on reality but rather on emergent phenomena.